I might have already sold that.
Got it.
Oh.
I'm sorry for bothering you guys.
Yeah, you should. You're good, Mike. See you later, man. Yes.
You mind if I put my phone in?
No, go ahead. They're not my plugs. As long as they don't get in my way. If it gets in my way, then screw it. All right, so we had a question in that first set of homework that, oh no. I forgot to put my markers down. Well, let's see if this one works. I got one marker. Probably doesn't work. Let's see what's going to happen. Oh, shit. All right.
You have to bring your own markers?
Yeah. It's cutthroat world. Yeah, this is it. This is the one marker. I left all my markers in my last class, so somebody else has them now. It's a game of markers. So there's a problem that started off like this. Oh, that's not going to work. I'm going to get you guys working on something and go get better markers. And then it tells you that x. It didn't have an x.
It was yeah,
What was
and
this?
then absolute value of x, and then x equals negative.
So by itself, there's no way to tell me the answer to this, because there's like two answers depending on what it is. But then they tell you that x is -2. So if you haven't tried this yet, take a second, make x -2 and try to see where that goes. Well, I look to see it. And when that left and marker. Alright, let's see. I might have found something. So they tell you that, let's see. Okay, that's better. They tell you this, so then you just rewrite this using the information you know. Okay, now here's where you really have to identify what level of PEMDAS we're at, right? Absolute value symbols are the same level as parentheses. So they get done first. Actually, whatever's inside you do first. Well, there's nothing to do inside. It's just a -2 sitting there. So then the next thing is you do the absolute value of -2. And can somebody tell me what this really is? What? Yeah, it's -1 times this. That's the level of multiplication. So yeah, so the absolute value of -2 is 2 times -1. Done. Okay. So there's another homework problem done. I like it. My colleagues are like, that's not how you do homework, Jeff. Don't do it for them. Yes?
-2 times -1.
Careful. There's no -2, is there? What is the absolute value of -2? 2 times -1. So there is no -2 up there. There isn't, because the absolute value of -2 is 2 times a negative. Bam. I like it. What's the difference? What if it would have been this instead? What can you do now? Now the parentheses don't mean an operation, so they're done. Then you can multiply and it becomes 2. But here, why can't you multiply this by this? Because you haven't done this yet. They're on the same level as parentheses and they have something to do. They want to make the inside positive, so you got to do that first. Here, these don't have shit to do, so I can multiply. That's the only operation there. How do you guys? Are you guys all right with that? All right, all right. I love that some of your expressions don't fit. Like somebody's like, "I'm fine." All right. Okay. Anything else from homework stuff? Even if you got a chapter 2, which is a little ahead of us, which is great. Okay. So let's do that. Let's get into chapter 2. And let me start off. I want to do something that you might have seen before. Actually, did I bring that with me? Oh, I need some help. Wait. Yes. You probably heard this kind of thing before. This isn't exactly what we're going to do, but I like to show people this because it kind of leads into what we're going to do. We're getting into solving equations, which is like the bread and butter of algebra, right? Solving equations. Word problems, universally, they're disliked, poor little word problems, right? a train leaves Wyoming going south, or Billy Bob leaves half an hour after Sally did, and Sally's going 20 miles an hour. Billy Bob's going 30 miles an hour. How long is it? Right? You with me? That's word problems? Yes? But when you get the equation set up, that should be the beginning of the easy step. Solving the equation should be the relatively easier step. So we don't want equations to be the big problem. So everybody do this for me. Everybody got a pencil, piece of paper? Like, yeah, we're college students. We got that shit. All right, you ready? All right. Pick a number and write it down. Any number you want to. You can be mean to yourself and pick the square root of 17. I highly recommend you don't. Just pick a nice whole number. You got it written down? Okay. Add 4. I'll do it with you. So I don't know if anybody picked this number.
Oh.
If you did, it's okay. Oh, you picked 71. Okay, I like it. Add 4 to it. So you guys all have different numbers, hopefully, right? I mean, just picking one. Somebody's added 4 to the number. Double what you got. Okay, so everybody's somewhere. Subtract 6 from that. Everybody with me? Okay. Cut what you got in half. And now subtract the original number. Yeah, you've seen that shit before, right? Now, if you did it correctly, what'd you get? 1. If you did it right, you got 1. So if you didn't do 1, maybe don't say anything. Somewhere something went a little wrong, but you should have gotten 1. So do you want to see why that works? I mean,
That's so cool.
you've heard stuff like, all right, number of TVs in your house. All right, now add your age. Now subtract the number of dogs you got. And you do all this stuff. You get 5. You always get 5. It's like, oh shit. And then algebra goes, well, of course you frickin' do that. So I made this so it would always come out to be 1. So if I'm going to use algebra and my first thing is pick a number, algebra is going to be like, I'm going to pick every number then. I'm going to pick every frickin' number. So what would that be? X. Beautiful. And the next thing I asked you to do is add 4. Right? And then I said double it. What do you get when you double this?
2x plus 4.
2x plus? 8. You guys kind of with me? Mm-hmm. Then I said subtract 6. Right? Then I said cut it in half.
1.
And then I said subtract the original number. So of course you're going to end up with 1. Oh shit, so you can see that's exactly what I did. I started with X, I did shit, so it would come out to be 1 at the end. You guys kind of with me a little bit? So every single thing you've ever heard like that is that. You can make it come out to be anything you want to be. I can make it come out to be always double your original. I can make it come out to be anything I want to because I'm an algebra dude. That's all it takes is doing the algebra. Okay. So, that isn't exactly solving equations, but it sort of is the flavor of how to look at where equations come from. And I want to be really careful with this because in reality, equations in the real world come from observations we make. How do we try to predict the weather?
You look in the sky.
Look at the sky alone. So back in the day, we'd go out and we'd look out and say, I think it's going to be dry, there's no clouds up there. And then half an hour later, it's rain. Unless you live in San Diego, and it's like, yeah, it's a 100% chance of rain, and it's just cloudy. It's San Diego rain, the sun's covered. Patterns, good. So you look for, so what you really do is, for weather nowadays, you have all these measurements you can take, all these variables. And then you have various computer models that try to take the variables and predict what's going to happen. So what I really think about, I used to live in Florida, and like our windows had tape on them always, so we were always ready for hurricane season. And so there's these models of where the hurricane was going to maybe be, I don't know if I know we live in San Diego. Hurricanes are like a myth. You used to live in Florida. So you remember the cone of uncertainty? And then there's that black line that's sort of like the average. I don't know, have you guys ever seen that before?
Yeah.
I might try to look it up in here a minute. And then, so you'd see, like, here's the hurricane right now, and then here's where they think it's going to be, and then you got this cone of uncertainty around that, and here's Florida, and we live there. Right? And then you wait a few days, and maybe it's gone here, and now, so it's you know. Anyway, sorry. So they have, where that comes from is they run like 7 computer models, and then they kind of average the results of each. And each one is somebody's own take on what they've seen in the past and how the variables should interact. So they create an equation where you can put all these variables like air density and water temperature and surface winds and all this shit. They can put all that into these equations. But how do you create the equation? There's a difference of opinion how those variables should interact. And that's why you got so many different models. Are you guys... We're not going to suddenly start doing meteorology, don't worry. Because that's like, oh shit, you need some supercomputers to help you crunch that shit. All right? Now, so what I'm trying to say is, we're about to do something that is not what happens in the real world, but I'm trying to show you how to solve equations. But the real world, where do equations come from? Very often observations, trying to figure out the theory behind how things work. That's physics. It's like trying to figure out is there a theory I've been set up an equation for and put shit in and then see if it's true. Can we make predictions? Well, we're not going to do that. We're going to do something a little, we can't go out there necessarily. We could, but we're not going to. Let's say we start with something we normally don't have in algebra. The answer. Let's say we have, let's say x is, give me a number.
15.
15. All right, I like it. So now watch. I'm going to create an equation. I already know what the answer is going to be. 15.
1.
No,
Just kidding.
I like it. Stay with me now. Now this is going to hopefully, well, let's just see how you feel. So if I put x plus 3, what should that be?
18.
18. What if I put 2 times x plus 3?
36.
36. I love it. And what if I put 2 times x plus 3 minus 1? 35. So what algebra does, this is the most fundamental thing about solving equations. I always look at equations like my variable is buried under shit. And I'm trying to just unbury the damn thing, right? You kind of with me? So, like, if I started here, and I know we're going to do some more basic equations in a minute. Let me just get a feel for how many people kind of know the steps here. If I want to solve that equation, I know we know the answer, but if I want to do algebra to it, I would just start undoing all the shit I just did, right? So, and actually, we might do it a little different order, to be honest. Let's see, what's the first thing I could do? You could add one, you could distribute, either way. So let's distribute, because that's normally what we do when we solve equations, right? So what do we get? And then you get here?
2x plus 5.
2x plus?
5.
5?
5.
So look what we're doing. We're trying to unbury the x, right? Which sounds like you've killed somebody you used to date, and I'm trying to dig them back up. No, sorry. That's morbid, Jeff. Too bad. Somebody out there is like, how does he know? Is that cool? So subtract 5, trying to get the x piece by itself. So here's where x is. If I had it by itself, I could just cut it in half. This stupid thing is here in my way, get rid of it. And really, what have you guys heard people say about how to solve equations? Get all the, have you guys ever heard it in? Get all the numbers one side and your variables on the other side. And the last thing you almost always do is divide. So we're almost there. We got all the letters on one side and all the numbers now are on this side. And of course the last step,
By 2.
almost always the last step is divide. And of course we get back to 15. Okay, so there's details embedded in there, but the general idea of solving any equation is really the same. Undo what's being done to the x. If I can get x by itself, I know what it equals, especially if Jeff wrote in English. Yes?
So if you divided by, when it's 2x plus 5 equals 35, if you divided the x and 5 and 35 by 2, then you get, you know.
Then it would work.
It'd be, but is that only in this case, or?
No,
is
no,
that
no,
also-
always. But the reason I say you almost always want to divide last is so you don't make fractions too early,
Okay.
right? If you had the option to not work with fractions, would you choose that way?
Yeah.
Oh shit, yeah. And look at me. Do you think I know math? And you're like, well, I hope so. You're some dude that walked in, knocked our real teacher on the head, and he's buried somewhere. Oh shit.
He's the X.
They're on to me. Yeah, he was. Yeah, exactly. So you guys see what I'm saying about? Okay, I like it. I know math really well, and yet I'm going to choose not to use fractions if I don't have to, because I'm also human. Fractions are an easy place to make mistakes. Negatives are an easy place to make mistakes. So if I can do it where I don't have to use those things, I will. Not because I don't know math, but because I'm freaking human. And I'm going to make mistakes in those areas more often than not. Or not more often. Okay. So let's do a couple of basic solve an equation problems. And then I've got some handouts, so I can shut up for a little while. I'll let you guys do some stuff. You're a loud one. All right. So the most basic idea of solving equations is like an addition subtraction property. So if I have x plus 2 equals 7. That barely qualifies as a math problem. Because if I just said to you, what do you add 2 to get 7? You know the answer is 5. Right? This actually points to a larger issue. If there's a new idea, sometimes we use the idea in such an easy format that you're like, what? Why does that idea even need to exist? This is too easy. Because things are not going to always stay that easy. Right? But algebraically, what would you do here? Yeah. Because again, the idea is to unbury the x. You're trying to get x equals something so then you know what the shit it is. So why is the x not by itself? Stupid 2. What do I do to kill it? Opposite operation. I love it. Kicking the ass. Okay. So x equals 5. It's amazing. And you can always check your work by putting that back in. 5 plus 2 is 7. Yay. I like it. Does every equation have an answer? Nope. Right? I can set up an equation that tells me what I have to do with my lemonade stand to make $3 billion tomorrow. And the equation will probably not be solvable because that's not possible. I'm not going to do that, right? It ain't going to happen. So yes, there has to be equations that don't have answers because equations model what we want to try to do in the real world, and we can't do everything. Too damn bad, no matter what this motivational speaker said. You could fly, try, oh shit. All right, so what do I do if I got x minus 11 equals 9?
Add 11.
Yes, so again, it almost doesn't matter what the operation is. Why is the x not by itself? Stupid 11. What's the 11 doing? Subtracting. How do I kill it? Add. You are really loud.
Oh, you meant the marker.
Yes, not you guys. No, I love the level of, trust me, I'm teaching another course and they don't ask anything that's going to drive me insane. Because I live off of questions. I'm like, okay.
Do they have to be math-related questions, or like where'd you get your shirt?
Math-related questions, much appreciated. This shirt, I don't know, it's really Patagonia. Probably Patagonia. So what about this one then? Yeah, so again, and again, I want to remind you guys, a lot of different backgrounds in math in here. So right now there are several people in here going, the shit is that? Of course I know how to do this. All right, shut up, appreciate it, right? Just sit there and appreciate that nothing's freaky yet. Some people in here are like, what's going on? All right, that's who I'm trying to reach. I used to always say, if I'm going too fast, slow me down. If I'm going too slow, deal with it. So yeah, what do you say to yourself? Why is the x not by itself? Stupid 5. What's the operation? Division. How do I kill it? Multiply. Both sides. And you can see it cancel. And so I get x equals -10. And sure enough, what's negative 10 divided by 5?
-2.
Negative 2, check. Sweet. Okay, good. Yes?
Do you want to, like, check out where?
If it says in the problem, check, you better do it. If it doesn't say, and you don't do it, I can't hold it against you.
You have a test like that probably? Or you just-
Probably I'll say check.
Alright.
Yeah. On a few of them.
Okay.
Yeah. Later this semester, we're gonna do equations where you have to know that there's a reason to check. Because we'll get to a point in math where we'll solve a problem, there's 2 answers, but one of them doesn't work. And it's not math's fault, so we'll talk more about it when we get there. Yeah.
Not math.
So sometimes you just have to know, I've got to check for this kind of problem.
Okay.
Okay. Okay, so let's try, now obviously what would you do here? I always wanted to make it so. Yeah. Because why is the x not by, now be careful though, watch. I was hoping you didn't say it, because you kind of knew where I was going, because it's one operation I haven't done yet. But do you see, what would you tell the person that you saw do this? And some of you guys might be like, well, that's what the hell I was going to do. So, what's wrong with that though?
It's not adding, it's not subtracting.
What's the operation right here?
Multiplication.
Can addition cancel multiplication? No. So a lot of you guys are going to see that on your homework and on a test or a quiz. I just wish it was nobody, but it's going to be some of you guys. I'm going to say addition can't cancel multiplication. Division can't cancel addition, right? So right there, this is what I meant the first time I said this. Always make sure what you're doing cancels out what you don't want. This isn't going to cancel multiplication. No good. So why is the x not by itself? Stupid negative 2. What's it doing? Multiplying. So then I have to divide. So the negative and the 2 cancels. X equals
-5.
negative 5. Kick ass. You guys with me?
Yeah.
Okay. So, let me see. Is that a good place to do this? Yeah. All right, I like it. So let's do this. I want to make sure everybody's on the same page with me. Just do, there's one side with a lot of writing on it, and then there's 4 problems. So do those 4. If you get done, you can look at the back. Get the 4 on the front done now. Everybody get that email I sent out about I did send an email about the blue book, the blue notebook lecture notes? I haven't sent that out yet? Shit. Sorry. I'll send that out. The bookstore, yes. Can you hold it up? See that little book? I thought for sure I said something. Maybe I said something about it. I didn't even. It's in the bookstore now. I am going to use that. It's what, $8?
Yeah.
That will help you with keeping your notes. One little thing, that one is set up to go along with the book that costs $100-something.
200.
Sure.
Yeah. So it's a little bit not the same organized as our free book, but I think we can deal with that shit, right? Yes.
Do we have to get
They said it's just the lecture.
that? Just for notes, you said?
Yes, to help us keep notes, I'm going to take a lot of problems out of there. So could you survive without it? Yes. Should you get it? Yes.
You got this in the system?
You have the what?
I've been telling this course already and I purchased that book that's a schooling color.
Only $8?
Oh!
The other one is
Was this last semester?
The actual one is cheaper.
I have this one.
Okay. I think they haven't changed it much since.
Like, it's still like any changes all
Yeah.
year. They did work.
Yeah. It shouldn't be that different if it's different at all.
Yeah, it's not, it's pretty much.
You guys are good.
All right, everybody knows what's happening. There's the side with a lot of words. There's 4 problems at the bottom. You might want to read through some of that I tried to write for you, some notes, and then try those problems out. You get done, you can try some on the back if you want to. Yeah, do the front for sure, those 4.